Hello everyone. Hope you remember in the last class we studied about energy bands in solids and band structures. What are the different type of bonding available in the solids? So in continuation of that, today we'll understand about the variation in the band structure, which makes them either an insulator or a semiconductor or a metal. So this variation in the band structure is basically responsible for the different range of electrical characteristics. If it is an insulator, there would be no possibility for an electron to pass from the valence band to the conduction band, or you can reach from the valence band to the conduction band. So there is no possibility for a current to flow. In semiconductors, which are basically have a high resistivity at you can say 0 Kelvin. However, the electrical properties can be changed with the help of some external excitation, source of excitation like thermal or optical excitation. So there they can be changed from an insulating behavior to the semiconducting behavior. And then we have metals, which are basically either have a partially filled or you can say overlap of bands. So this is the band structure, typical band structure at 0 Kelvin. Now these are the insulators which have valence band completely filled, and this is the conduction band which is empty. Same is the case with the semiconductor as well. The basic difference between a insulator and a semiconductor is that that lies in the band gap. In case of insulators, the band gap is very large. So even after you can say you can excite the electrons from the outside, they will not be able to overcome this band gap. So there would be no flow of current at all. However, in case of semiconductors, because the band gap is small, at 0 Kelvin they are basically like that of an insulator. However, with the source of some sort of excitation, either you can say thermally, optically, or any other source of excitation, electron will gain sufficient energy. They lose this valence band and they can reach to the conduction band, and they will remain there as soon as they will remain there till the time you have maintained that source of excitation which is greater than or equal to this particular band gap. So electrons will remain in this state, and whenever they come back to the valence band, they either come through direct band gap or through indirect. So which we will study later on in the categorization of semiconductor, and based on that we will categorize as direct semiconductor or indirect semiconductors, wherein if the electron is coming straightforward from the conduction band to the valence band, so energy is giving in the form of photons, then it is a direct band semiconductors which can be utilized for the for potential applications like lasers, LEDs. And if it is indirect band gap semiconductors, then it can be of different applications. Then we have metals. They are where the valence band and the conduction band are partially filled, or they are overlapping each other. So this is the typical band structure, the theory I mentioned here. In case of silicon, it is a valence band completely filled with electrons at 0 Kelvin, the conduction band is empty. So there can be a no charge transport, or there can be, you can say, no transport of carriers from the valence band to the conduction band. So semiconductors are basically insulators only at 0 Kelvin. However, difference lies in the size of the band gap, which is small in case of semiconductors as that of the insulators. We can see it from the band structure itself. So what is the conclusion here? Conclusion is that in semiconductors, the number of electrons that are available for conduction, they can be increased subject to the source of excitation from the outside which we are doing. Or the metals, they either have a you can say partially filled or overlap of the bands. So metals, that's why they have a very high electrical conductivity. Moreover, we understand in the case of metallic bonding, because metals have sea of electrons. So with the application of the electric field from the outer, they can accelerate very well, and they are free to move anywhere because of the partially filled of the outermost shells. So tomorrow we'll continue with the direct and indirect semiconductors. So just go through it. If you have any doubt, drop a message. Thank you.